Okay, so now that we know what is the difference between descriptive analytics, predictive and prescriptive analytics, let's move on to really understanding the core components of this field, called big data analytics. Now again, just to clarify, big data analytics used to just mean big data infrastructure at some point, right? But now when somebody says, hey, I'm doing big data analytics, they're not just using the infrastructure but also doing analytics on top of it. And therefore it has become like, it's interchangeably used with data science, information sciences and so on. So therefore now as part of big data analytics, a whole bunch of things make sense as part of it, right? So big data infrastructure is one. So this is the core piece. This is basically the basic software that runs across hundreds of machines that allows you to use hundreds of machines as if it was one big monster, right? One big mammoth machine, okay? So, and we'll talk about details of each of those, right? Data mining. So data mining is about, given some data, can you find patterns from this data, right? So humans work by patterns, right? So imagine yourself on Mars, out of nowhere, right? And there are all these Martians around talking in their language, right? Unless you can figure out some patterns in the language, you don't understand that, right? So you understand the language only when you understand symbols in it, right? You understand words in it. You figure out some patterns, you understand the language, right? And that's what the aim of data mining is. When you see huge amounts of data, can you sort of try to understand some patterns out of it? Right? And when you understand the patterns, you can do wonders. You can do very interesting things. We'll talk soon about what all is possible under data mining. Right. Machine learning. So machine learning is about building those predictive models. So it's about making a machine learn, as it says. Just like making a child learn, it's making a machine learn, right? Very recently, in the last 4 or 5 years, what has become popular is deep learning, which is more or less an extension of machine learning, an extension of neural networks part of machine learning, right? Now if you also want to mine some interesting things out of text or out of speech, which are generally called as natural language data sets, okay, then you need to do NLP, okay. So as against formal language like C, C#, Java and so on, Hindi, English, Marathi and so on are natural languages, right? So, and that is why any processing that you do on top of them is called natural language processing, okay. For example, if you just heard Modi's speech, right, a 30-minute speech, right, can you write a summary in automatically create a summary or automatically create a news report, right? And this automatic stuff of course should take less than a minute, right? Can you do that automatically, right? That's a part of natural language processing. That's one of the killer use cases where natural language processing can do wonders, right? And there are many other typical use cases that we'll talk about. Next one is information retrieval. So, as the name says, it's retrieving information from a large amount of information which is available, right? So, or from a large amount of data which is available. So, when you search on Google, information retrieval is the thing that Google is doing for you, okay? You have a query, you basically say flight from Hyderabad to Bangalore, and Google looks through like billions of those web pages, huge amount of data which is available, and retrieves the right pages that make sense for you, okay? And that's what is information retrieval. Now, information retrieval is not just Google, right? It's about retrieving the best results on your desktop search, or it's also about library search or patent search or Carvali search or Naukri.com search. All of those portals have these search parts, right? Have these search modules, and information retrieval is the thing that pumps these modules, right? The next one is web mining, okay? Now, it's a very generic name. So, what can you mine from the web in general, right? So, and this sort of relates to all those web pages that you have. So essentially, from these web pages, what are the things that you can extract for your purpose, okay? So, for example, if I wanted to know, all cities in the world, so just get a database of all cities in the world, where can I get that from, okay? So, if I wanted to know, given my product, what are people talking about it? So, are they happy with the product? Are they unhappy with particular features of the product, right? So, I can read blogs, right? And I can read tweets and then come up with that conclusion. But how can I do that automatically, right? All that is a part of web mining, okay? The next one is social network analytics. So now, of course, a part of web is about social media, right? And social media is very useful. One of the use cases already talked about, sentiment analysis from Twitter, so as to know, what people are talking about my product. But there are many other use cases that we will talk about when we talk about social networks. And again, some social networks, so Facebook is not the only social network, or Twitter is not the only social network. There are many networks where these same methods that we will talk about are applicable. Okay. So for example, they're applicable on a water flow network, they're applicable on road transportation network, they're applicable on enterprise networks like Yammer, which you might be using inside your companies, right? So these network analytics methods are applicable across a whole bunch of graphs, right? And there exist many of such graphs. So now the last two are Internet of Things and visualization. Machine learning, acts or works after you have data. So once you have data sets, you can try to use it for prediction, solve certain kinds of business needs, and so on, right? How do you generate very awesome data, right? How do you generate data in scenarios where it has traditionally never been generated, right? For example, can I collect data about electricity usage of each of your machines that runs at your home every minute, right? If I can do that, I can enable a bunch of use cases. So for example, electricity boards can actually enable variable pricing for electricity, right? Maybe I'll charge like ₹9 per unit in this hour, because in this hour India-Pakistan match is going on, right? And when the India-Pakistan Cricket World Cup is going on, sure, everybody wants to put their TV on, right? If there is peak demand on my electric grid and I know exactly what people are doing, I can do variable charging and tell them, hey, basically schedule your washing machine sometime later. Okay? All these interesting predictive prescriptive use cases are possible thanks to Internet of Things. Internet of Things is bringing in sensors at places where they never were. Okay, and therefore enabling us to gather those data sets as well, okay, and which ties in back to these things. Once you have data from new sources, you can actually do data mining on top of them, machine learning, predictions, prescriptions, and so on. Okay. Finally, when you do all of this, after you've done all of this, to pitch your case to customers, you need to know exactly how to pitch it, and nothing is possible without good visualization. And that is why even various nice ways of visualizing is also part of big data analytics. Okay. With new kind of data sets coming in, you can actually do visualization in much better ways, right? And we'll talk about that.